So on yesterday, we navigated our way through vertex form, which is a parentheses x minus h squared plus k. As we were graphing, we saw that the axis of symmetry is just the h value. The vertex is the h and the k value put together. The y-intercept, you're not required to find it. Granted, if you were to find it, you would plug 0 in for x and then solve out the function. Of course, make your table, do your graph, state the domain and range. In addition to graphing, we found max and min and converted vertex form into standard form. So that's what yesterday took us through. Today we're essentially going to be doing the same thing, graphing, max and min, converting to standard form, but now we're going to use intercept form. So intercept form is also known as factored form. It's also known as factored form. So with intercept form, your y equals a parentheses x minus p, x minus q. So a, p, and q represent numbers. The a value, when you take it, you will take it as is. The p value and the q value, since they are both in parentheses, you would take the opposites of them. You would take the opposite of them since they're inside parentheses. So to give you an example of how this would be identified, y equals 1/2 parentheses x minus 4 x plus 1. So that would mean that a is equal to 1/2, p is equal to 4, the opposite of minus 4, positive 4, q is equal to -1. So that would be your identification of a, p, and q. Another potential example is something along those lines. So notice that your a value is -3. The first x is not in parentheses. You don't have another parentheses. So that means your p value is 0. And your q value is -2. So the reason why p is equal to 0, if x is by itself, then this is the same thing as -3 parentheses x minus 0 parentheses x plus 2. The opposite of 0 is 0. So again, identifying p and q correctly will help you when it comes to solving out the problem, especially for the graph. So with that, let's go ahead and do the graph. So there's a little bit more work with intercept form than it was with vertex form. Vertex form was pretty straightforward. Intercept form is a little bit more work. So example 1, f of x equals x plus 1 parentheses x minus 3. So if we identify the a, p, and q, a is 1. There's no number in front of the parentheses, still 1. P is -1, Q is +3. Remember, you take the opposites of the numbers inside the parentheses. So, find the axis of symmetry. That's P plus Q divided by 2. Take your P and your Q values, add them up, divided by 2. Similar to finding the midpoint. So -1 plus 3 over 2. So 2 over 2, which is 1. So your axis of symmetry is x equals 1. Vertex. So remember, your vertex is an x and y point. The x value is the axis of symmetry. The y value is you plug in the axis of symmetry. So we're going to take 1 and plug it back into the function. 1 plus 1, which is 1 minus 3. 2 times -2, -4. So your vertex is 1, -4. And just as I emphasized yesterday, the axis of symmetry and the vertex should lie on top of each other. Any questions before we continue? Alright, then moving on. So in intercept form, we don't worry about the y-intercepts. P and Q actually serve a special purpose. Those are your x-intercepts. Hence, this is why they call it intercept form. So your x-intercepts are P, 0, and Q, 0. So whatever your P and Q values are, you make points out of them. You make points out of them, and they go in your table. Now, the nice part about intercept form is that those are the only 3 points that you need. Those are the only 3 points you need to draw your graph. We now have 3 points. So draw your parabola. You do not need 5 points for intercept form. So we've got our axis of symmetry, our vertex, we have our x-intercepts, got our table, got our graph, so the only thing that's left is domain, which is -infinity, +infinity, and range. The graph opens up, so you start with the y value of your vertex, comma, That's it, our first graph is done. So the main things that you would need to get for intercept form are axis of symmetry, vertex, your x-intercepts, your table, your graph, and of course your domain and range. So it's not as much work as standard form. It's not the relatively light work that vertex form was, somewhere in the middle. So let's pause for a second. Any questions on example number 1? Don't be shy. That's okay. We are doing a second example of graphing. So let's do that. So example 2. G of x equals negative parentheses x minus 2 parentheses x minus 5. So since there's a negative out there in front of the parentheses, that is the same thing as negative 1 x minus 2 x minus 5. A value negative 1. P value, remember, take the opposite, it's 2. Q value, take the opposite, that's 5. Yeah, most people make their mistakes by not taking the opposite. So let's go ahead and work out our graph. Axis of symmetry, P plus Q divided by 2. So that's 2 plus 5 divided by 2. 7 over 2, 3.5. Yes, sometimes your axis of symmetry is going to be a decimal. That is what it is. 1, 2, 3, 3.5. So there's your axis of symmetry. So your vertex, remember, is a point. So your y equals negative parentheses 3.5 minus 2 parentheses 3.5 minus 5. It's negative 3.5 minus 2, 1.5, and negative 1.5. 2.25. Yeah, feel free to check me, make sure I didn't do anything computationally wrong. I am human after all. Check in my calculator, looks like I'm straight. 3.5, comma, 2.25. So that's your vertex. So when you're plotting 2.25, do the best that you can. I'm not going to penalize you if it's a tick off of where it should have been. 3.5, 1, 2, so 2.25, somewhere right there. Not quite in the middle, but somewhere right there. Any questions before we continue?
I think that the negative 1.5 minus 1.5 is negative 3.
Minus 1.5?
Isn't that what you did? Like above that 2.25, you did negative parentheses 1.5 minus or times that multiply.
That's multiplication.
Oh, my bad. Never mind.
Yeah, all of that is multiplication. It's all good. Any questions before we continue on? Alright, so we got axis of symmetry, we got the vertex. Now we need our x-intercepts, which is p comma 0, q comma 0. So we know what our p and q are, so that's 2 comma 0 and 5 comma 0. Notice how conveniently that you get one on one side and one on the other. So again, remember with intercept form, you only need 3 points. There's your 3 points. There's your curve. We have our table, you have your graph. Domain is negative infinity to positive infinity. Range, the graph is opening down. So it's negative infinity to the y value of the vertex, 2.25. There's all the stuff that we need. Questions, example 2. Okay, graphing is not as labor intensive as standard form is, but it's not as straightforward, easy as vertex form is. Intercept form for everything. But alright. So aside from graphing, there's still max and min and rewriting it into standard form. So as far as max and min are concerned, so remember, max and min is based off of the a value. A greater than 0, you have a minimum. A less than 0, you have a maximum. Once you identify that, your minimum or maximum value is equal to the y value of your vertex. Which means you're going to have to get the axis of symmetry and the vertex in order to figure it out. So again, same rules apply. So for our function, y equals 4 parentheses x minus 2 parentheses x plus 7. A is 4, P is 7, oops, that P is 2, Q is negative 7. So a is equal to 4, which is greater than 0. So that means you're going to have a minimum value. Figure out what you're going to have first. Then you can actually solve it. So to get the minimum value, you need the y value of the vertex. To get the y value of the vertex, you have to find the axis of symmetry. P plus q over 2. 2 plus negative 7 over 2. Negative 5 over 2, negative 2.5. If you want to leave it as a fraction, negative 5 over 2, that's fine. It's more so your personal preference. So, there's your axis of symmetry. You got a question to do? Just popped off. So, you got your axis of symmetry. Now we do our vertex. Vertex, take your axis of symmetry and plug it in. 4 times negative 2.5 minus 2. Negative 2.5 plus 7. That's negative 4.5. 4 times negative 4.5 times positive 4.5. So all of those numbers are getting multiplied together. So negative 81. So your minimum value is negative 81. So if you're looking for a maximum or a minimum value, figure out what you have, find the axis of symmetry, and then find the vertex. Any questions in example 3? Alright, so example 4. So last example. Write the given quadratic function into standard form. So if you have something in intercept form, you've got a double set of parentheses. You're converting it to standard form. Which has no parentheses at all. So this is a situation which you're going to be doing some FOIL. Doing some distributive property, multiplying the problem out. So you have 3/2 times x plus 6 times x minus 4. So I'm going to start with the parentheses, because that's what order of operations tells me to do anyway. 3 over 2 parentheses x squared negative 4x plus 6x is 2x minus 24. And then I distribute. 3 over 2 x squared. 3 times 2 is 6. Divided by 2 is 3. 3 times 24, 72. 72 divided by 2, 36. for it to see if you can get it foiled, and then strip the file. Two steps gets it knocked out. Questions, example 4. Alright, so that in and of itself summarizes the graphing part for a quadratic function, whether it's in standard form, which is what we did at the beginning of the week, vertex form, what we did yesterday, or intercept form, what we did today. The format that it's in indicates to you which way you're going to solve it out. Now, there are some of you that will try to do everything in standard form and rewrite it and then try to graph it that way. That's your choice if you choose to do it that way, but you're adding more work to yourself by virtue of doing it that way. But hey, if that works for you, you do you. So, go ahead and split that.